Welcome to this explainer on Coding 101. Look, if you've ever felt a bit intimidated by computers, or maybe you thought programming was some kind of dark, inaccessible magic, I just want you to take a deep breath. I'm here to guide you through this. Programming is at its core simply the ultimate tool for problem solving. It's what allows you to automate tedious tasks, build entirely new digital worlds, and literally bring your ideas to life. And while computers might seem overwhelmingly complex from the outside, they're actually quite simple once you know the basic rules they follow. So today, we're going to take a patient, steady walk through your very first steps into programming. Okay, let's dive into this complete beginner's syllabus. We're going to cover what exactly programming is, the Lego rule of syntax, storing your important data, directing the program's flow, and finally, packaging your code and fixing bugs. You can really think of this as your step-by-step roadmap to mastering the absolute fundamentals. All right, part one. What exactly is programming? Let's demystify the so-called dumb computer. So right out of the gate, we need a foundational mindset shift. We naturally tend to think of computers as these super sophisticated, hyper-intelligent geniuses. But in actuality, computers are really kind of dumb. Programming is simply attempting to get a computer to complete a specific task without making any mistakes. The machine is literally just sitting there, patiently waiting for your perfect instructions. If we don't guide it flawlessly, step by step, the entire outcome just completely falls apart. Moving on to part two, the Lego rule of syntax. This is all about how we actually speak the machine's language. Which begs a pretty massive question, right? How do we talk to a less than intelligent computer? The computer's brain only speaks in raw machine code, binary ones and zeros. And let's be honest, that's practically impossible for humans to write quickly or efficiently. We absolutely need a way to bridge the gap between our human language and that raw binary code. To solve this, think about trying to get a friend to build a Lego set. If they're a typical human friend, you can just give them some general casual English instructions. Easy enough. But what if your friend lost the manual, requires exact piece-by-piece digital placement, and, to make matters worse, only speaks Mandarin Chinese? You'd need a middleman translator. Well, programming languages act as that exact middleman. They take your English-like commands and translate them into the precise binary instructions the computer actually needs. But to use that translator, you've got to play by its rules. Enter our next concept, syntax. Syntax is really just the programming grammar and the set of rules for a specific language that you absolutely must follow to a T. I know, learning grammar rules sounds incredibly tedious, but it's essential. And honestly, don't worry, you don't have to catch every single typo yourself. Programmers use software called an IDE, which stands for Integrated Development Environment. It basically acts like an insanely smart spell checker to catch your syntax typos before the program even tries to run. And here's a classic example that brilliantly illustrates why those rigid grammar rules are so entirely necessary. Missing a tiny little semicolon in your code is exactly like missing a comma in the sentence, "Let's eat, Grandma." Without that comma, you get, "Let's eat, Grandma." The entire context is completely, hilariously ruined. One small punctuation mistake, and suddenly your computer misinterprets everything you wanted it to do. Okay, part three, storing your important data. Think of these as the cardboard boxes of your code. Once you can successfully give the computer instructions, you need a way to help it remember dynamic, changing data, like a player's score in a game. We do this using a variable. A variable is just a designated space in the computer's memory used to store information. To make this super concrete, imagine a regular old cardboard box. You take a Sharpie, write score on the outside, and toss a piece of paper with the number 10 inside. As the game progresses, you can open that box, erase the 10, and write 15. The physical cardboard box stays exactly the same, but the data inside is constantly being swapped out and manipulated. So how does this scale up? What if you have a massive list of related data? You wouldn't want 1,000 individual cardboard boxes scattered all over your room, right? While a single variable is great for one piece of data, an array is more like an Excel column or a neat bookshelf. Arrays allow you to keep massive lists of related items, like a grocery list or a database of usernames, neatly organized in a fixed, structured space where the computer can instantly search through them. Let's move to part four, directing the program's flow. This is where we get into making decisions and looping. Up until now, our hypothetical code has basically been running top to bottom in one single rigid sequence. Conditional statements completely change that. These are instructions like if or else that alter the actual path of our code depending on whether specific conditions are true or false. Just think about it. Without conditional statements, a video game would play out the exact same rigid way every single time you open it. But by telling the computer, hey, if the player reaches level 5, then make the enemies harder, your code suddenly transforms into a dynamic, reactive world. And this brilliantly illustrates our next powerful concept, the loop. A loop is exactly what it sounds like. It's a statement used to run certain instructions repeatedly as long as a condition is met. Imagine you're building that game and you need to create 100 bad guys. You could manually type out that creation command 100 painful times. Or you could write it exactly once, wrap it up in a for or while loop, and just let the computer do all the repetitive heavy lifting for you instantly. Finally, Section 5, packaging code and fixing bugs. Let's finish building out your tool belt and talk about finding errors. As you start writing more complex instructions, your program is going to get very long very quickly. To keep things clean, we use functions. A function is just a segment of code wrapped up into a reusable package that automatically runs whenever you call its name. Think of it as a beautifully wrapped present of code. Instead of typing out all the complex mathematical steps to calculate a player's total stats over and over, you write it once, wrap it up in a function named printStats, and whenever you need it, you simply call its name to open that present. It saves you an enormous amount of space and time. Okay, but here is the absolute best part about functions. You don't even have to write all of them yourself. There's an incredible quote from the source material that sums this up perfectly. Why chop down your own wood when you can go to Home Depot to buy materials others have already made? In programming, you can literally import libraries of pre-written functions that other developers have generously shared. It's exactly like walking into a digital Home Depot and grabbing a fully built math package off the shelf. You just plug their brilliant work straight into your own code. Now look, as you combine all these elements, you are going to make mistakes. Bugs are completely 100% normal. There are 3 main types you'll run into. Syntax errors are just your standard typos that your IDE will catch for you. Logic errors are when your code runs fine, but human error makes the underlying math wrong. But runtime errors, those happen when you ask the computer to do the impossible. The source actually gives a hilarious analogy for this. It's like telling your friend to sit on the couch and wait for an infinite The Office joke, but you put Friends on the TV. They will just sit there waiting forever. Well, the computer does the exact same thing. It gets stuck waiting infinitely until it completely crashes. So when your code inevitably crashes, I really want you to remember this. Do not panic. Debugging logic errors is just a calm, steady process of elimination. First, just read the console error message carefully. It often points you right to the exact line of the problem. Second, use print statements to see exactly what the computer is thinking right before things go sideways. And third, comment out suspect code to temporarily hide it from the computer, which isolates the problem area. Just take a breath, act like a detective, and follow the clues. So, what does this all mean? It means you now understand exactly how to communicate with the machine. You know the strict rules of syntax, you've got the cardboard boxes of variables, the dynamic power of loops and conditionals, and those beautifully wrapped packages we call functions. You now possess the coding blueprint and the complete beginner's tool belt. The only question left is, what world will you build first? Take these concepts, be patient with yourself, and just start writing. Thank you so much for joining me on this explainer, and I absolutely cannot wait to see what you create. All right.